I'm with the Exploratorium. I'm actually with the department upstairs over here. Called, hi. I'm with the department upstairs over here called the Teacher Institute. We actually teach middle and high school science teachers, and I've been there a long, long time. Before that, I was actually a high school science teacher. I taught physics, chemistry, a whole bunch of other stuff. Actually, somebody know the name of this is Fire and Ice, right? Okay, so we're gonna have a little bit of fire, we're gonna have a little bit of ice. Actually, a lot of it. So I just want to bring up the fact that, and this is important, it's gonna be a little bit, there's some danger to this, so try not to come too close. You can kind of see the stanchions over here. You can see fire extinguishers located, fire extinguishers located around. So I'm just gonna start by saying, kids, don't try this at home. What I want to do is I want to first talk about the difference between most of the ice you're going to hear about and this ice over here. So most of the ice you're going to hear about over here is water ice. You know, it's water, it's frozen, and then now it's ice. Chemical formula for ice is what? Chemical formula? H2O. And right over here I have. Here we go. Oh, you know what the formula of this one is? No, this I wouldn't be holding it. You know what this one is?
H2O.
It's H2O cubed. Get it? Thank you very much. Thank you very much. What's that? And this over here, this is dry ice. Anybody know the formula for dry ice? CO2. Yeah, it is really cold. Really cold. Carbon dioxide, just like the stuff you breathe out. And by the way, you breathe out about 4% of what you breathe out is carbon dioxide. So I will mention this is about 0 degrees or so Celsius, so it melts, freezes at 0 degrees. This stuff over here, this melts at 79 degrees below zero. So it is cold, cold, cold. This stuff, you put it on your fingers, hold it in your hand, maybe it'll get uncomfortable after a while. This stuff, if you hold it for a while, it will freeze and it will give you frostbite very quickly. So when I use this, if someone sees me touching that for more than like a second or two, tell me, what are you doing? And I'll put my gloves on. I gotta get my gloves on. I got gloves, I got goggles, I got a whole bunch of things over here. Hey, speaking of the cold, really cold. You know how cold this is? Should you be afraid of this, by the way? Oh, how cold is it? Very cold. You know how cold it is? It's so cold. Hold on, let me get it. Come here. This is your second show. Yeah. So cold. Here we go. We got, yeah, there you go. Coin there. You want to come over here? It's the advantage of coming here early. You should be very afraid of it. You want to do one?
Yeah, I can.
So what I'm going to have you do something. I'm going to have you back off to the side to show people what's going on. So this is what you're going to do. You're going to take a coin. Oh, by the way, it is so cold that even the dead people on this are afraid of this thing. So this is what we're going to do. Is we're going to go up to this ice right here. I'm not touching it for too long. And you are going to take your coin and you're going to push it down maybe about a millimeter or two. And when I say you're going to push it in, and then you're going to push it in fairly hard, then you just let go and back up. Okay? Does that make sense? Show you how scary this stuff is. Here we go. So push it in. Come on, everybody. Wait, hold on. Everybody, get in here. Ready? Okay, push it in.
I've got my own coin.
Push it in. Yeah, maybe at the end. Okay, let go. Let go. Wait, I'll get that. No, don't worry about it. Come on. Is it going yet? Come on. Come on. Come on, get going. Is it doing it yet? Nah. Man, I'm just going to tell you, the 7 o'clock show.
They all started spinning.
They all start. Hold on. Hold on. Yeah, the ice is defective this time around. Okay, thank you very much. Oh, here we go. That one. I'll do this. If anybody wants to do it at the end coming over, I'm just going to give this one away. The coins are supposed to shiver and shake. We'll do that one later. Sorry. Does anybody have really warm coins on them? Yeah. Come on over here. Really warm coins. Okay, now let it go. There we go.
It's sugar.
Anybody else a really warm coin on them? Yeah. You got one? Okay, come on. Tell you what. There you go. Okay, so cold.
You can keep that, teacher.
So cold. The coins are afraid of it, but I got to tell you that the ice is afraid of knives. It is so afraid of knives that when you bring a knife near it, it screams. Very afraid of knives. I'm sharpening? No, I'm not. Dulling. So it turns out that ice, very cold, it doesn't melt into a liquid. It goes right from a solid to a gas. It skips the liquid phase. It's called sublimation. And it turns out, even though we only had one coin that was successful, which I'm bummed about, it turns out that, by the way, anybody take my coin? It turns out that when you put the coin in it, everyone saw with the coin wiggle? When you put the coin in, it literally melts, not melts, it turns the solid into a gas and it literally blows it to the side, and the other side blows it back. And so it wiggles because it's actually being blown back and forth. This one over here, it's already getting too cold. But what happens is when I push it down on that, the dry ice right there is sublimating, turning into a gas. Don't do this at home. So what it's doing is when I push down on it, it's actually pushing it up with the gas, and then I'm pushing it down and it pushes up with the gas, so it's actually vibrating. Make sense? What's that? It is not the light and frost effect, but we'll talk about that later. Yeah. Yeah, so also, oh, here's the ice. What happens when I put ice in water? Does it float or sink? It floats. So what does that tell you about the density of regular ice? More dense, less dense than water? Less dense than water. What about dry ice? What do you think? I don't know. I have no idea. Let's find out. Use your gloves. Come on. Come on, Eric. So what does it do in water? It's turning into gas, but where is it?
At the bottom.
It's on the bottom. Luckily, it's on the bottom. So it sinks to the bottom. I don't recommend chugging this. So you might see people, oh, what is that? It's like soda. Yeah, so it turns out that when dry ice bubbles in the water, it carbonates it. So I'm turning this into soda water. So billions of people every day drink basically this, but not as cold. And luckily, it's denser than the water, so that it sinks to the bottom, so I wouldn't chug it all the way down. But as long as you're careful, I think you've had enough. As long as you're careful, you're good to go. Also, water, which makes regular ice. What state is water in? Like at this temperature, room temperature? It's what is water at this temperature? It's California. It is a, what is it? It's a liquid. What about this stuff? This stuff is still really, really cold. What is carbon dioxide at this temperature?
Yeah.
Let's find out. So at this temperature, it's a gas. So just to let you know, if something goes wrong over here, hopefully it won't, don't use that fire extinguisher. It's not going to be able to put out what I'm about to do. Use that fire extinguisher over there. And so, use the yellow one. So what I'm going to focus on now, is what makes up carbon dioxide or dry ice. So the formula is CO2. That means there's carbon in there, there's oxygen in there. Have people heard the term there's too much carbon in the atmosphere? Or there's carbon that's buried in rocks? Or we use a lot of carbon in our fuel. Everybody heard that?
Yes.
So in theory, I don't know, maybe there's carbon in here. We're going to see if we can get that carbon out of here. But I will show you this. This is kind of the carbon that we're talking about. I mean, this is real carbon right here. This is actually coal. This is called anthracite. So this is real coal. This is what carbon looks like in its natural form. It's kind of, I'm not going to pass this around because it's very black and it will get all over your hands. But we're going to see if we can get that black stuff out of the carbon dioxide, okay? And in order to do that, I'm going to use a helper, and that helper is, where is my helper? Oh, my helper is right here. My helper is a metal that we're going to use to do a chemical reaction, and the helper is magnesium. Come on, magnesium. Hold on. The helper I'm going to use is magnesium, and what I'm going to do is first I'm going to burn this magnesium. Oh, by the way, before I burn this magnesium over here, I'm going to taste it. What do you think magnesium tastes like?
Banana.
I will say it tastes like bananas. Yeah. No, it tastes like metal. It's metallic tasting. So there you go, metal. Thank you very much. So what I'm going to do is, hopefully I can find this with these goggles on, is I'm going to light that magnesium on fire. And just to let you know, magnesium really, really wants to bond with oxygen. And it burns incredibly hot when I do this. You're going to see this in a second. It burns over 2,000, actually over 2,200 degrees Celsius, so it burns really hot. And it burns so hot, it also gives off UV light, okay? So do me a favor, don't stare directly at it. Don't stare in the light. Don't go to the light. So try to kind of look at it in your peripheral vision. Does that make sense? You will know what I'm talking about in a second. And I need to put this on correctly. So this is burning incredibly hot. It should go out pretty soon. And so the interesting thing about this is, what color is this now? What color is that? White. And so I'm just going to tell you this. The white indicates the magnesium metal combined with the oxygen in the air. This is now called magnesium oxide. And the interesting thing about magnesium oxide is it helps me become a regular guy. If you take magnesium oxide and you put it on your tongue, it combines with saliva to make magnesium hydroxide, which is a laxative. So I'm a regular guy now. So I'm going to use the magnesium to help me get the carbon out of here, okay? Oh, by the way, what color is magnesium oxide?
White.
That means that grab the oxygen. What color is carbon?
Black.
Black. So let's see if we can do this and make this happen. So I'm going to take some magnesium metal. More? Okay. Even more. What do you think? More? Yeah. Okay, let's do this. I want to get the new stuff also. Is this the new stuff? I'm going to put a little bit of the new stuff in, the good stuff. This is the good stuff. Yeah, that's good. You'll actually see this is a little bit oxidized, a little bit, but there we go, even more. Yeah, it's got a different kind of color. Okay. So, put a little fuse in there.
All of a sudden, the filmmakers passed away.
Okay? So this is what I'm going to do. I'm going to burn this magnesium metal inside of 2 sheets of carbon dioxide. So I'm going to light this on fire and slam up, and I'm going to slam this one on top, and I'm going to let it burn, okay? And we'll see what pops out. And hopefully, I'll be able to see what I'm doing. So it's like a little campfire. We could sing Kumbaya. Oh, did I mention don't look at it? No, it's okay to look at it. So, like I said, this burns incredibly high. And obviously it was burning inside of there. A whole bunch of this magnesium came out too. So it's cooling down now. It's going from 2,000 degrees down to a temperature we can handle it. And it was, hopefully there's still some left there because a lot of it shot out through here. So when we open it up, what should we find? Talk to a partner. What do you think we're going to find inside of there?
White.
If this really is carbon dioxide. Got a guess? So what's the white stuff? Magnesium oxide. How did it get the oxides? It was slammed between 2 sheets of dry ice. Where did it get it from? It got it from the carbon dioxide. If it takes the oxygen from carbon dioxide, what's got to be left? Carbon dioxide. I'm going to pop this open.
I knew it.
See the black stuff? Black stuff?
Yeah.
That's the carbon. It's inside of carbon dioxide. So when they talk about the carbon in the atmosphere, there is carbon in this. That's it. I'm all done.